Okay, we're going to work on this 4-5 part of the packet here, but we're going to start with number 2 in here. And the first one says a simple closed figure in a plane formed by 3 or more line segments. So here's actually an example of 3 being connected. What did I just create? A triangle, but I could do it with 4, and I could do 4 sides connecting. I could do 5, I could do 6. What do we call all these figures? By the way, you can, with my stuff, you can tend to look at the next problem and find the answer. That's called a polygon. Okay, did not write that very well. Okay, the next part here, the polygons that have the same shape are called, well, there it is down here. They're called similar polygons. Parts of similar figures that match are called the corresponding parts. And if 2 polygons are similar, this is actually something you should be able to answer from your last video, then their corresponding angles have their same measure. Therefore, we say that they are congruent. And we say that their corresponding sides are proportional. Also got that from the last video. Okay, so let's go ahead and determine whether these 2 rectangles here are similar rectangles. And let's see here. We know that their corresponding sides have to be proportional. So the ratio of 7 to 3, which were the ratios of these 2 sides here, must be proportional, which means we can set them up in a proportion as 10 is to 6. All right, cross multiply 7 times 6 is 42. Cross multiply 3 times 10 equals 30. Those 2 numbers have to be the same for them to be proportional, and they are not. So the answer is no, they are not proportional. The answer to number 6, those 2 rectangles are not proportional. And why not? They're not similar because their sides are not proportional. Their sides are not proportional. Okay. All right. So go ahead and figure out if, using the same idea, can you figure out if the triangles in number 7 are similar? So I set up a proportion with their corresponding sides. Big side is to little side as big side is to little side, and that's how I set it up here. Cross multiplied, I got 8 times 8 is 64, 6 times 12 is 72. Those are not the same, therefore they are not similar. Okay, the ratio of lengths of 2 corresponding sides of 2 similar polygons is called the scale factor. All right, in other words, how much bigger or smaller is one thing from the next. So looking at, we start off in this particular square that has a side of 6 and 6, and we are going to change it to a square that's 3 and 3. What did we multiply it by to get that? Well, 6 times what gives me 3? That's a scale factor of 1/2 to get there. Okay, now this is where we can really, this is probably the best part, most important part for you to pay attention here. We're going to try to figure out the measure of xy. There's supposed to be an x here, okay? And in other words, I'm actually trying to find the size of length m, okay? And I look at it, I need to set up a proportion. I know that these 2, this things that tells me that the polygon here are similar. That little squiggly line says that the polygon ABCD is similar to polygon WXYZ. And I need to set up a proportion. I'm going to go ahead and just leave a blank one in there. And I know I have to include the m, so I'm going to throw that m in there. And I also know that I'm going to need to find its corresponding side on the other polygon is the 12. So the 12, and I have the choice of either putting it under the m or across from the m. I like putting the corresponding sides right across from each other. All right, and now I have to find 2 sides on both of them. I'm going to see, can I use this 24? Is there a corresponding side with it? No, there's nothing there I can use. Could I use this 13? There's no corresponding side over there. But what I can use, I realize, oh, there's a 15 and there's a 10. All right, so M was from the bigger polygon, and it has a side of 15 on that same polygon. And the smaller polygon had the 12, and now its corresponding side with the 15 is the 10. All right, so now I have a proportion. I can go ahead and cross multiply 10 times M equals to 12 times 15, and I get 10M equals to 12 times 15. Probably the easiest way to do that in my head is 10 times 15, which is 150, plus 2 times 15, which is 30. That gives me 180 when I add those together. And then I'm going to divide both of these by 10 to get M by itself, because M is being multiplied by 10. All right, and now I end up with M is equal to 180 divided by 10, which is 18, okay? So this is a really important lesson. This is how you can use, as long as you have 3 pieces of information in here and you have one unknown, and you can use a proportion to find that last piece of information. All right, so let's take a look. So I'm going to ask you to go ahead and find the answers to these. Actually, you don't have to do 2 through 5, just do questions 3, 4, and 5. Find the answers to those and then check with me. Okay, so first one, I found that they were, the triangles are definitely not similar. When I cross multiplied, I did not get the same answer. In number 4, I actually tried it 2 different ways. This one's a little bit tricky though, so I want to try to highlight a little bit for you here to show you how I did this one. So I took the biggest side, which was 18, and the corresponding, and I noticed also that that's in between the angle that has 3 bars and the one that has 4 bars. So again, I'm finding the biggest side on this one is the one with 3 bars and 4 bars, or sorry, I think I'm looking at it the other way, 4 bars and then 3 bars there in between that. So that's where I found that 18 is the corresponding side with a 13.5. And then I chose to use this side here, which was 10, which is the corresponding side on this one. Well, 10 is in between 1 bar and, in this case here, I have to zoom in a little bit more on that. It's between the 1 and the 3, and the 4 rather. So in between the 1 and the 4 was the 7.5 there. So the 13.5 is corresponding to the 18. And in this case here, the 7.5 is corresponding to the 10 here. So that's going to be this part right here with the 10 with the 7.5. I also did it a different way. I looked at some other sides, the 8 and 10 and 6 and 7.5 as corresponding sides. I also used those angles to help me figure out which ones were the corresponding sides there. And finally, so those were similar figures. And finally, I am just solving for x in this one. Again, for number 5, I need to make sure I'm using the corresponding sides in the right spot. So I'm taking, in this case here, the x. What is its corresponding side? I notice that it's between the 2 and the 3. So I'm going to look for where is between the 2 and the 3. And that's going to be this side over here, which I've covered up now, which is the 6. All right. So I have x here is to the 6. And then I know I also use this side here was the 6, and the 6 was between the 1 and the 3 of the angles here. That means the 3 is the corresponding one over here. So 6 and 3 are corresponding. Then I cross multiply and solve for x, and I get x equals to 12.